Welcome to our cloud storage options. I actually want to start off by talking about the company Dropbox. I'm assuming everybody's heard of them. If not, Google them, get up to speed. How many of you know that Dropbox uses 100% AWS cloud storage? Okay, just about everybody. Okay, how many of you, when you found out that Dropbox uses 100% AWS cloud storage, thought, dang it! Why didn't I think of that? that's totally my feeling when every time I think about Dropbox. I mean, think about it. Okay, they create a Windows client that watches a folder, and when you put something in the folder, it uploads it to Amazon S3. Oh, birth of a multi-million-dollar company. And then they add, later on the Macintosh, iPhone, iPad, Android clients. But essentially changed the face of the world to where now people are like, oh, I'll just throw it in Dropbox. I can get it from anywhere, right? That's now the mindset. Sometimes the simplest ideas are best. So that's what we're going to talk about is AWS cloud storage offerings, S3, EBS, Glacier, and even ephemeral storage. Well, let's start off with the biggest, baddest, and I'll say first of them all, and that's AWS Simple Storage Service, or what everybody calls S3. And I know you're like, what does that have to do with S3? I don't know. I went to Google Images and typed in Amazon S3, and I mean, come on, when you see a picture like that, you can't not use it. So there it is. So what is S3? It is not what you think it is. When you first think about storage, you think of a file system, right? Where it's like a hard drive. You got the needle, it's running. You put it in a computer and boot your. That's not what S3 is all about. S3, I would characterize it as more of a database feel. That's really, as the more you deal with it, that's what it feels like. Now, Amazon is very secret ninja of what's really going on behind the scenes, but their design for S3 is that this is internet accessible storage. So, S3, this is how S3, I don't know if you knew this, but S3 was out and in use years before EC2 even came about. You might say, well, why would you have storage without servers, in the cloud at this? Well, then you start thinking, okay, well, wait a sec. This is like leased space, which is accessible via HTTP and HTTPS. I mean, think of it this simple, right? You go to eBay, right? And you want to sell your pig. And so you put your pig on eBay. There's your little pig image, pig, buy it now for $59.99, whatever. And eBay gives you the option. They say, hey, do you want to store your image of your pig on our server? Or do you want to store the image of the pig on your server? Because if you put it on our server, we're going to reduce the quality to this certain size and all that kind of stuff. And he was like, no. I want to store it on my server. That's where you can actually bust out AWS S3 because you can say, I just want to put my big old picture of a pig up on Amazon, in the full screen resolution, and then link that directly to eBay. And eBay doesn't have to worry about the storage space to put all these pictures because you're storing it, and that's a pig, by the way. You're storing it in S3. Right, this is really good for, and I'll put video, audio, images, backup, and can I just quantify that as stuff? Just stuff that you want accessible. You don't have to have it web accessible, but just think of it like an object store. As a matter of fact, Amazon started coining the phrase blob store. You might have heard that before. That's kind of what they're talking about. You throw anything in there. It's unlimited bucket size, and that's what they call it, by the way. Instead of being like a directory, they say, okay, you've got an S3 bucket, and you can put whatever you want in that bucket with unlimited size. Every object in there can be anywhere from 1 byte all the way up to 5 terabytes. So I could have, a pig picture that's so high resolution that it's a 5 terabyte picture of a pig. So you can put that into the S3 bucket. Now, this is priced on storage, used, and transfer out. Anything that you put into the bucket is free. And Amazon, think of Amazon's business model. They're probably like, well, sure, we'll take your stuff all day. You don't have to pay for bandwidth at all because we know that once it's in there, that's where the billing begins because it's based on your storage used. And it varies based on the region that you put S3 in. But I would say one of the biggest claims to fame is that the super reliable, scalable, and fast is quantified down here with S3. Not so much. I mean, so you've got an SLA. Let me define the difference between SLA and durability. SLA means how much guarantee is it that this will be available? I mean, that somebody will come to my eBay page and they will see the picture of the pig there, and Amazon says, well, we'll actually back that with a 99.99% availability. Like our servers will be online 99.99% of the time to send that to you. Durability means what are the chance that the object will be lost. And they're saying actually it's 99.9999% durable. Now, you might look at that and say, that's just a number. What does that mean? Well, I'm going to actually read straight from Amazon's website here. It says, this durability level corresponds to an average annual expected loss of 0.000, I mean, think of this with all zeros and then 1 at the very end. Percent loss. So what does that mean? So for example, it says if you store 10,000 objects in your bucket, you can expect to incur a loss of a single object every 10 million years. Now, okay, got it. That puts it in perspective. This is very durable. Now you might say, well, how do they do that? I mean, how do you get that durability? Well, what you do is you replicate it across many different devices. 2, 3, I would say probably 3 is the minimum, 4 devices, with each one of those devices being RAID 5. Each one of those devices might be in a different data center, and that's one of the things with a region is you can have S3 span across the areas of the region. Availability zones. That's the phrase I was looking for. I don't know why it was escaping in my mind. So when you store something in S3 in a region, it's actually putting that data on multiple devices across multiple data centers, which contributes to this high SLA and high durability. Now, keep in mind, nothing replaces backups, right? If this is in a region and there's a nuclear holocaust in that region, then you can take that durability and throw it out the window. Still continue to back up your data. Also, if you delete stuff out of there, it's going to be deleted from all the different locations of S3. So don't skip backups because you start thinking, 10 million years, that's great. So anyway, okay. Last thing I'll mention on S3, Amazon engineers really frown upon things that treat this like a file system. What I mean by that is a lot of individuals, as soon as they find out that Amazon has this big unlimited storage in the sky, they're like, sweet, I want to be able to map a drive in Windows or OS X to the cloud and just store stuff there as a map drive and treat it like a file system. What I mean by map drive, if you haven't heard of that before, is go to computer like this. For instance, I've got this map drive this is a little NAS box inside of my house, just a little actually a Synology storage unit in my house. So that's actually, look at this. That is one of the utilities that Amazon would frown upon. Gladinet actually makes I'll call it quasi-free utility that allows you to map, in this case, my Z drive to an S3 bucket in the sky, so I can just store stuff there. Now that treats S3 like a file system, and that's not what it's meant to be. This uses what's called the REST API. It's a famous API that's used to make procedure calls. Essentially, how do you interact with S3? It's through the REST API. So just like a web server, you get items from there. That's a get command, or a put. I can put items from there. It's not meant to be a file system. For instance, if you map a drive to S3, you can actually go in and install programs to that drive and try to run programs from there, and try and do file sharing and all kinds of. So Amazon's like, that's not what it's designed for, and if you do that, you may end up with file corruption because it's not meant to handle that. You may end up with your computer freezing and locking up and running slow, and people are like, what's the deal, Amazon S3? And Amazon would reply right back, that's not the design of S3. What is designed to be a file system is Elastic Block Store, or EBS storage. Now, this file system, unlike S3, is not web accessible from the buckets in the sky like S3 is, but instead are only available to your EC2 instances. And that's where we originally talked about EBS, was we were saying, okay, well, EC2 by default uses ephemeral storage, so we might want to have a more permanent use, so we'll bring an EBS volume into it, which is the equivalent of a disk drive. Now, it's not like a big mechanical arm at AWS, as soon as you say, I want an EBS volume, it's like, it adds it to your EC2 server. Instead, now this is Jeremy's theory behind the scenes, because of course Amazon doesn't tell us, but more than likely they have a SAN or a NAS, storage area network, or network attached storage, however Amazon is configuring it, that when you add an EBS volume, I'm sure this is RAID 5, and they say, okay, well, this is striped across that NAS unit, and I'm going to add a portion of that to your EBS volume. Or as an EBS volume to your EC2 instance. Now, Amazon does say within the availability zone, they will have that on a couple devices. So it will be replicated. So it does have a higher level of resiliency, of durability, I'll say, than, for instance, just adding a single disk drive to a device would. However, it doesn't have that same 99.999% level of durability that S3 does. So again, there's no replacement for backups, even on S3. So this is the persistent file system. I mentioned that. Oh, this does not need to be attached to an instance. So you can have these kind of, I don't know why I think of severed limbs when I think of this, but when I think of an EC2 instance that's running and you've got an EBS volume attached to it, you can actually detach that EBS volume. It's like chunk, you pull it off. It's like you rip the disk drive out of the EC2, and then you can move that elsewhere. That's handy because you can have your entire EC2 instance existing in solely EBS. So, for example, let me give you an example, and this is where I'm going with this. Whoa, let me just cross it out, right? You can actually have, let's say you are in the Oregon region, right? And I think, I don't quote me on this, but I think Oregon has 3 availability zones. Now, EBS volumes are created in an availability zone, right? Now, you get free, quote unquote, free bandwidth between the availability zones inside of the Oregon region. So when you create an EC2 instance, it will be tied to that availability zone and to instances there. Well, you can take that actually the method you use to transfer it is snapshot it. You can take that EBS volume, detach it from the instance, or you can even keep it attached and snapshot it, which puts it in S3. Then you can come over here to availability zone 2 and go into the S3 bucket and generate a new EBS volume in availability zone 2 for the snapshot that you created in S3. Now, you might say, well, what's your point, Jeremy? The point is, I mean, that EBS volume could contain your entire operating system for Windows web server or an Apache, whatever, well, I should say a Linux, whatever, whatever you're doing over there. You can take those drives and replicate them so you can have instances created in all the availability zones across. Now, and I got to be careful with the verbiage. When I say replicate, I mean snapshot them to S3 and then generate new volumes across. So it's kind of cool. So we can detach these EBS volumes, and all you do is pay for the storage at that point, and the rates differ based. It's I think just below S3 storage. So if S3 storage for Oregon maybe is 11 cents a gigabyte, then maybe EBS will be 10 cents a gigabyte. But again, just check the rates to see that. Now this is, I mentioned this, not internet accessible. It is not like an S3 bucket where you just get web links on there. And it does support incremental snapshots. Now, I mentioned a snapshot just a moment ago. What do I mean by incremental snapshots? What I mean is, let's say we've got a EC2 instance, and it is running, maybe it's just a file store. Maybe we've got this guy attached to an EBS volume that is storing files from, maybe we've got a little, I always think of a website where our users can upload pictures to us. Maybe it's a photo sharing website where they can do whatever, right? So we're storing all those files on an EBS volume. Even as I say that, I'm like, no, actually, I'd probably prefer S3 for picture storage, but just go with me, right? Okay, so we're storing all these photos on an EBS volume. We can have Amazon take snapshots of it. So let's just say we've got 10 gigabytes of photos on this EBS volume. Our first snapshot will go to S3, and it will be 10 gigabytes in size that will be stored. It's the exact replica of that EBS volume. Well, I can say, well, in another hour, why don't we take another snapshot? And what it will do is the difference between this snapshot and this one. So maybe since then we only had, half a gigabyte of information added between the first and second. Well, our second snapshot will only contain half a gigabyte of data. But when we go to restore, Amazon is smart enough to say, okay, well, let's restore the snapshots and combine them all together to bring back that one EBS volume as it was. So the beauty of that, I mean, if you've ever dealt with backup software, you call these incremental backups. The beauty of incremental backups is you're not every single time you do a backup taking another 10 gig snapshot, 10 gig snapshot, 10 gig snapshot, and paying for that in S3 storage. Instead, you're just paying for the changes between the first snapshot and the second. Now let's talk about Glacier. Glacier storage. It's actually one that's near and dear to my heart because I use it personally. Anytime I use something personally, I'm like, here's a perfect use for it. But you can stretch this to anything, personal, business, wherever. It is insanely cheap storage for backup, meaning you're paying a penny a gigabyte. Let me first off tell you how I arrived personally at Glacier. I have at my house this little NAS box, and it's actually Synology. 1511 plus. I think DS 1511, something like that. So it's 5 individual hard drives that are a terabyte each that use RAID 5 altogether, which gives me 4 terabytes of total storage. Now, an average normal person would say 4 terabytes. Good grief! What are you gonna use that for? Well, I have 4 children that are 6 years old and under, and a few years ago I bought my wife a really nice fast camera where you can hold down the button. It's like ta 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 ta. And so when you take a picture of your son walking, and each one of those pictures is 5 megabytes in size, and you hold the button down, you can't delete any of them because you're like, but look, that half step is so much cuter than the step. I can't delete the step. So we end up with literally 4 terabytes of photos. I'm running out of stuff and movies and all the other stuff that we record digitally. Well, it creeps you out when you go totally digital because you start having the what if factor. What if my house burns down? What if somebody breaks in and comes after my Synology NAS? Because this is actually a really nice device. And by the way, I get nothing from recommending it. I'm just telling you, if you want a really nice device to store stuff on, grab that. So you get that, I don't want to lose my family photos and all that. So we thought, okay, this, when we first investigated AWS, this was actually a long time ago, all that was there was S3. They didn't have Glacier yet. And so I did the math. I'm like, okay, well, let's, carry the 1 here. I'm actually going to do it right now. Wow, that was a brilliant calculation. So I just did, okay, if I've got 4,000 gigabytes, which is 4 terabytes, and then I multiply that by 10 cents a gigabyte. Wow, amazing how that works, right? So $400 a month is what it comes out to replicate all of my data to S3 because it's about 10 cents a gigabyte. And now that's hard for me to swallow. If I'm wanting to back up my stuff, I'm like, I'd rather buy another Synology unit and then store it somewhere else, maybe take it off site every couple of weeks rather than pay $400. I mean, that's a car payment, right? So when Glacier came out, I was thrilled because that takes it down to $40 a month. Now that I'm like, okay. I could kind of see that. $40 a month, still a little like, ooh, but at the same time, for assurance that all of my stuff is being stored offsite with the same durability as S3, that's pretty good. I'm kind of okay with that. So Synology, and the reason I bring this up is they actually came out with a plugin that allows me to back up my data directly to Glacier. Now, there is some stuff that you need to know about Glacier. Why do they call it Glacier? You've probably read ahead of me, right? Retrieval time expectations is 4 to 6 hours. Now, it doesn't always take that long. It might be 2 hours, it might be 3 hours. And now when I say, what do you mean, Jeremy? What do you mean by retrieval time? I mean, to even get to the point where your data is accessible for a retrieval. Right? Are you getting that? So now I have 4 hours, and then I can start copying my 4 terabytes of pictures back down, right? Now, there is a price. There's always a price for data transfer out of AWS. So you will start paying for restore. But, I mean, again, if it's your family photo library, or let's now go business, it's your SQL database that you have to restore because it has customer records that they are requesting from 2 years ago. Those kind of things are what Glacier is all about. It's not time sensitive, because if this is the case, my guess, again, Amazon still doesn't say, but my guess is they're using some kind of very high density tape storage, backup tapes for this. I mean, that's kind of what goes along. Either that or they've got little men in golf carts driving around the data center trying to find where your data is at. So the storage vaults are tied to a specific region. It uses the same interface as Amazon S3. It actually kind of integrates with S3 in that way. You can encrypt all of your data that's on there so you can feel confident that it is secure. So Glacier, right? That's about all I have to say about it. Now the one thing to be aware of on this, and this is what throws a lot of people, because there's a lot of now consumer tools that allow you to interface directly with Glacier, is you go back to get a listing. Listen, my emphasis was on that. A listing of what is even in your storage vault in the Glacier world, and what they will tell you is, oh, well, I'm retrieving that and retrieving it. And so the same thing, even to get a directory list. I mean, you're talking about hours before you really get a full if you have a lot of data up there, a full directory list of what exactly is up there. So again, slow Glacier. I mean, that they named it well when they're talking about Glacier. But when you're looking at a penny a gigabyte, that is an amazing price. It's time for something that's absolutely free, and that would be ephemeral storage. I thought I'd start that way just because everything is like a penny a gig, a 10 pennies, whatever. Absolutely free storage with the purchase of EC2. Now, I'm sure if Amazon had a document saying, here are our storage options, ephemeral storage wouldn't even make the list. However, I find there is so much confusion when I talk to people and they go, well, wait a sec, where's that server running from? I just wanted to add it to the group so that everybody is aware of it. This is absolutely free storage that comes with an EC2 instance. So this is local storage running on the server. So you've got your instance, right? That you go through and you generate a new EC2 instance, and it says initializing. You see that big initializing thing. What's happening is Amazon is actually copying the data from the AMI, which is usually stored in S3. They're copying that data onto an actual server in that initializing phase and beginning to run that server on there. Now, the big question is, where are they copying it to? Well, those servers all have local storage, probably RAID 5 is my guess, a local storage that all the instances running from that server come from. Now, the thing that I want to make sure I mention is right there, access speed is not guaranteed. Meaning, if you look for an SLA for ephemeral storage, you won't find one because it's really just shared among all the other people that happen to be using that same server with you. Now, of course, anytime I say people using the same server with you, security, it's don't worry about security. Yeah, don't. What's that statement to a security auditor, right? Don't worry about security. It's all fine, right? But again, I'm taking you back to the Amazon security documents. We talked about that earlier in the series. I just don't want to retread the same ground. But if somebody, customer X who has a large instance really starts hitting their server hard, doing some reporting or processing on there, then that local storage may be hit hard as well. There's no guarantee of your actual speed. How do you get a guarantee? EBS. So with EBS, you can get a guarantee of performance because they have EBS with, I should have mentioned this when I talked about EBS. They have provisioned IOPS. Where you can say, well, I will pay more and more and more depending on how many IOPS you want, which is IO operations per second. That's essentially how many operations can your hard disk do per second. The more IOPS, the faster it is. So you can pay more to get a guarantee on performance with that. Now, so that gives you the feel. Now, depending on your company, hard disk performance may not be a big deal. I mean, I'll say a lot of people just run like a Linux web server where it boots up, everything's memory resident anyway, it very rarely hits the hard drive, whereas other companies might be doing a lot of reporting, database actions, transactions. So those kind of things you might want to use to move to EBS. Now, I know we're talking about this is kind of off the beaten path. I just wanted to make sure I covered everything here. You guys know this, right? Ephemeral, I mean, if you look it up in the dictionary, it means temporary. It's going to be destroyed when you terminate your instance. Now, I will say some people, and I think even the Amazon documentation, this is probably why people say this, say even if you reboot your instance, you will lose all of the data in ephemeral storage. I have not seen that to be true. And when I say reboot, I'm talking you go into the AWS console and you right-click on that instance and it gives you that drop-down menu and it'll say start, stop, terminate, reboot. If you choose reboot, I have yet to see it lose the data from ephemeral storage, although documentation in some places say that you will. But I don't think that's true. So what was I going to say? Okay. performance. So, a couple ways to increase your performance. You know, ephemeral does not guarantee access speed. EBS, I just mentioned you can pay for the provisioned IOPS, but something that people were doing long before provisioned IOPS was even available. That's a more recent feature that Amazon just started offering, those provisioned IOPS that you can pay for speed. Is they would actually take an instance and mount multiple. For some reason I'm having deja vu, like I've mentioned this earlier in the series somewhere, and that's okay because it's worth mentioning again. They take multiple EBS volumes. Let's just say they're 10 gigabytes each, and then inside of the operating system. So these now present themselves to the operating system, which we'll say is, let's just say it's Windows, because that's what I'm running on right now. Windows will see those as an individual disk it can manage. I just brought up my disk management. So for instance, if this were an instance running inside of AWS, you would actually see disk 0, disk 1, disk 2, disk 3, disk 4. You'd see it all however many EBS volumes here. And you can actually hold down the Shift key in Windows and, well, I don't have it here, and actually select the space on all those disks and combine them together into what's called a RAID 0 volume. Now, I know some of you are like, oh yeah, got it, no problem, fast forward, right? So if you haven't heard of RAID 0, what it is striping without parity. So you can actually stripe data across all of those EBS volumes and then gain the performance of those EBS volumes all writing and reading at the same time. It's a big performance boost. I mean, we can say theoretically, when you take 2 EBS disks and do RAID 0, you double your performance of whatever it was before. You take a third disk, you triple your performance. Now, I say in theory because there's all kinds of other overhead associated with that, so it's not going to be exactly double or exactly triple, but nonetheless, that is a quick way to get a big performance boost. And do the cost, see what provisioned IOPS is getting you, and then you might look and say, okay, well, what does RAID 0 get me? Now, the only thing that I want you to be aware of is when you are going RAID 0, it is striping without parity. That means if any one disk in your RAID 0 stripe is lost, you lose all the data on that disk. So we could call it risky, but with the way Amazon does their EBS volumes, I would say it's a minimal risk, but the fact is the risk is still there. So I think, I don't want to keep saying this throughout the series, but hear me say it one more time. Backing up your data is just key. Run a snapshot on that EBS stripe set every hour or whatever, however sensitive that is. Okay. Finally, I want to take you all the way back here, and just the last thing I'll wrap up with, not to show you the pig and the kid again. I know, it's gross, but it's funny, it's cute. But this just made me remember there was something I forgot to mention when I was talking about S3, and that is there is standard storage and reduced redundancy storage available. What I mean is this. S3 standard gives you that 99.99999 level of durability for all of your storage, but Amazon realizes that there's some data that you might not want that for, and what they do is they say, well, we will give you reduced redundancy for that data at a cheaper price. So you might get, again, just throwing prices out there, maybe a normal S3 bucket costs 10 cents or 11 or 12 cents a gigabyte, and a reduced redundancy one might cost 7 or 8 cents a gigabyte. Now, it's going to still be redundant. It's still going to be replicated in multiple places. However, it's not going to be that level of guarantee. So you might say, well, who on? Actually, I remember sitting in the class. We were talking about this same topic, and somebody asked the question. They go, who in their right mind would do that? Who would say, oh yeah, I don't need that? And the answer I thought was brilliant. Maybe you remember S3 is web accessible, so maybe your bucket has these video files that people are submitting. Let's just take cbtnuggets.com. CBT Nuggets, this video that you're hearing right now, is streamed out of S3. So when I upload this video to S3, my original version of it is very high quality. As a matter of fact, when I look at my little Synology storage at home that I mentioned, most of that goes to these videos because it's super high quality. Why? Because then CBT Nuggets has a little engine where it generates all the different formats, an iPhone version, or I should say a mobile version nowadays, right? A web version, a high quality, a low quality. So they've got all these different formats. So maybe CBT Nuggets would say, okay, well, we're going to store the original in S3 full durability, whereas all these little offshoots, which still consume a huge amount of space because it's essentially rendered video, maybe we use the reduced redundancy for that because worst case scenario, if we lose an object out of there, that's okay. We can regenerate that from the S3 original video that's there. So again, it might be thumbnails for pictures. It might be, I mean, just look at the stuff that you're doing, and you have to look at it and say, is there stuff that is not as valuable, that's expendable, if you will, if we end up losing it? Great selection for reduced redundancy. Now, the beauty of Amazon S3 is that they allow you to choose down to the file level which ones are using standard and which ones are using reduced redundancy storage. So you might have this bucket with all these different folders, and you can actually go in and say, actually, just that folder, maybe that's iPhone versions, right? That are being transcoded. Just that folder is reduced redundancy. All these other ones are standard storage. So very flexible with how you want to mark them. All right, well, let's wrap up. I laugh just because every time I do one of these nuggets, I think, oh, this'll just be 10 minutes. Like I never realized just how much there is to talk about each one of these things until I get into it. I'm like, man, there really is a lot to every one of these storage locations. And then you throw Jeremy's personality somewhere, and they're talking about kids licking pigs, and here we are. Anyway, let me wrap up. We've talked about every single storage option that's available today at Amazon Web Services, the features, functions of each one of them. Without breaking apart each one, I'll just say you saw it here first. Anyway, I hope this has been informative for you, and I'd like to thank you for viewing.